Greetings and welcome to today's video on inflammation. The goal of this video is to introduce the effects that histamine causes when released from mast cells or other immune system cells, and thereby creating a cascade of events currently and commonly known as inflammation. So let's get started. The process of inflammation is a crucial process to the body to essentially promote healing. Inflammation is the body's natural way of producing a cast and protecting an area that has been damaged until healing and repair can occur. There are some key players that are going to be important in the inflammation process. The cells that are able to mediate this are going to be distributed throughout tissues in the body. Mast cells. These cells are embedded in tissues throughout the human body and are designed to release a signal, that signal being histamine. Now, not only mast cells produce histamine, there are some other cells that can produce histamine, although not to the same degree. For example, one of our second line of defense cells, known as the basophil, also can contribute to histamine production in the body. Basophils will be a tiny bit limited in the amount of histamine they release, however, because they are located in the circulatory system, and to release a lot of histamine in the circulatory system could potentially be detrimental due to the effect that histamine has. The first effect that histamine has on tissues, and specifically blood vessels, is to cause vasodilation. This is going to increase blood supply to the damaged area and bring in other cells like other white blood cells to help contribute to and heal the process. This increase in blood flow also supports the metabolic demand of the tissues, as in the healing process will require some mitosis. And mitosis means feeding cells and providing all the nutrients and nucleic acids to support that mitotic division. Also important and key is response of endothelial cells, or blood vessel cells that line the blood vessel, to increase capillary permeability. White blood cells are reasonably large, so in order for them to exit circulation, they're going to need more gaps in the blood vessels to allow them to be able to move out into tissues. So the two main effects of histamine are to target receptors in blood vessels, in small blood vessels, and increase the dilation in the area as well as the permeability to further support healing in the vicinity. Let's draw a quick picture to try to illustrate the events that are going to take place and how a mast cell is going to be triggered, as one example, to release histamine. So we're going to start by drawing some skin up here. And we're just trying to draw the surface, the area that the skin is going to be located. Now, in the skin, in this cheesy example that we're going to use, we're going to pretend that something has impacted the skin. This could be really anything. This could be a paper cut, but in this case, it's going to be this gnarly splinter. And the key to that gnarly splinter is that the gnarly splinter is going to be bringing things from external of the body internal to the body. So this can include little bacteria, right? But in addition, when this splinter entered, for the cells that are usually located in this area, right, they're going to have been punctured and stabbed and pushed out of the way. And so over here, this splinter will have caused some damage. So as this splinter comes in and brings with it some microbes, now the body needs to start thinking about protecting itself and trying to make sure that things are good. Now the mast cell has the ability to respond, and the mast cell can respond a couple of ways. One, it could literally be poked, right? Poke this cell and we start to see an effect. So mast cells are going to make histamine. Okay, and we're going to label this histamine. And this is going to be our chemical signal. And that histamine is pre-made. This mast cell is waiting to be able to use this histamine when it's needed. So one way that a mast cell will release histamine is if we poke it and we jab it. And in this case, that can cause the histamine to be secreted or to be released. But in addition, anytime that we start to see some tissue damage, these injured cells are going to need to be cleaned up, and they can signal to the mast cell like, we might have foreign invaders coming in. We might need to do something about these pathogens that have gotten into the system. So when damage occurs, mast cells are going to respond by doing something that they cheesily call degranulation, meaning that these granules of histamine are going to be secreted outside of the cell. And now that I have histamine outside of the cell, this as a signal is going to be able to impact or influence tissues in the area. Now your skin has a whole area where there are no blood vessels, but deep in your dermis there are blood vessels. And so these blood vessels ordinarily, for example, might only be about this wide. That's the blood vessel. But when histamine is around, histamine is going to be able to come over here, right? Bring some histamine over. And this histamine is going to bind to the cells in the blood vessel. And the blood vessel, remember, is going to respond one of two ways. The first thing that it's going to do, right, one effect, is to vasodilate. So we're going to draw this blood vessel much larger now to show that dilation, and this is going to improve blood flow to this area. Now that improved blood flow is going to help us with a couple of things. One, this area is now going to turn red. But with increased blood flow, we're also bringing warm blood through this area. We're also going to start to develop heat in this area. Now, heat is a critical component to altering the ability of the enzymes of this microbe to be able to function. And anytime I elevate the heat, just kind of like warming up for exercise, if I can elevate the temperature a little bit, I can support the cells over here that are going to be doing the mitotic divisions and replacing and healing themselves when that splinter is either ripped out or once the splinter has moved its way out of the skin. So, blood vessels under the influence of histamine are going to vasodilate. The other thing, though, is if we look at this blood vessel and we consider the inside, it's lined with simple squamous epithelium. It's lined with a single layer of flat cells. And these single layers of flat cells allow things like water and nutrients, wastes, oxygen to diffuse back and forth to these tissues to support the cells that are in this tissue space. But those gaps aren't big enough for a white blood cell to be able to leave. So what happens is that as this vasodilation has increased in size, right, the gaps, the spaces between the simple squamous cells also enlarge. We call that an increase in permeability. So this cell becomes more permeable to molecules, this organ, I should say, becomes more permeable to molecules being able to leave. So now water on the inside is able to leak out through these gaps, and giant white blood cells, right? The macrophages, the T helper cells, the neutrophils, we'll put an N in here for a neutrophil, are also going to be able to do a process of margination. They're going to kind of tumble along to the edge, and they're going to be able to squeeze their way out of this gap that was formed by the increased capillary permeability. And that increase in gap then allows those neutrophils to enter into this tissue. And once the neutrophil is out into the tissue, it then can start moving around and it can look for where it needs to be and potentially, oh, come on. We're going to get over here where those microbes were present and the neutrophil will be able to start digesting that. Now, if this liver was not likely to naturally remove or perhaps got cut off so it's embedded down in the skin, the presence of the neutrophils in this area will be helpful because those neutrophils are going to be able to digest and become pus to remove those microbes, but that addition of pus actually lubricates this area a little bit and allows that sliver to pop right on out. So let's summarize what we just visited about. Okay, step number 1, injury. So we'll put a 1 over here and the word injury. In this example, that injury is coming from a splinter that is penetrating into the skin. As the splinter comes down, that's going to cause tissue damage. And that tissue damage is going to negatively impact that tissue and start to release some chemical signaling. And if a mast cell is either poked or signaled, it can start to release histamine. So step 3 is the release of histamine. When histamine is released, it's going to look for receptors, and receptors are located on blood vessels. Those blood vessels are going to respond one of two ways. First, a blood vessel can increase its size, vasodilate, but also the gaps between the cells that line the blood vessel can also loosen up. That's going to be step 6. And that step 6 is the process of increased capillary permeability. Now, increased capillary permeability is going to allow more water to move from inside the blood vessel out into the tissue space. Additionally, those larger gaps provide an opportunity for something called margination. Margination being the process by which white blood cells are able to slow down, grab a spot, and squeeze themselves between the epithelium of the blood vessel to end up in tissue. Once in tissue, those cells, like neutrophils, are going to be able to start circulating around. They're going to start moving through the tissue, looking for the foreign invader, looking for what needs to be cleaned up and anything that needs to be destroyed. That includes ideally finding their way over to where the damaged tissues are located. So 7, things start to leak. 8, neutrophils find their way to the damaged tissues and begin to clean up particles in this area. As neutrophils do this cleanup, sadly, they die in the process. They're kind of sloppy eaters, so their enzymes digest themselves as well as the things that they are hunting, and that's going to lead to a buildup of dead neutrophils. Those dead neutrophils are going to create pus, and the benefit to pus is that if the splinter is still in place, this is going to help actually loosen up this splinter and allow it to be removed more easily. If there's no splinter in place, we still may see some pus development, but those neutrophils may also then hop back in a blood vessel and get carried away and cleaned up. Time for our key ideas of inflammation. So when inflammation occurs, it involves a process in which mast cells, keyly, predominantly, release histamine, although there are other cells in the body that can contribute to histamine release. Histamine is the signal, and that's the most important part. When histamine is released, any tissue with a receptor is able to respond. And the tissue that responds to histamine is going to be the blood vessel. So when we look here, we have our blood vessel. This is our normal blood vessel, but when histamine is released, one key effect is vasodilation. In the vasodilation, this is the key effect where the blood vessel is going to open up in size, and this is going to allow more flow to the area. That has 2 effects. The first one is an increase in temperature, or one of the cardinal signs of inflammation we refer to as heat. Essentially a little temperature in this area to improve the metabolic activity and support the healing, but also perhaps to make it slightly uncomfortable for the microbes in those areas, to maybe push them outside of their most desirable range of growth. In addition to heat, we also are going to see another cardinal sign of inflammation known as redness. Redness is going to improve in this area because when I bring more blood flow and I open up capillaries, we're going to see that kind of flush color indicating that that vasodilation piece of inflammation has begun. Now remember, another effect of histamine when bound to the receptors is to cause an increase in capillary permeability. So again, at the bottom of the screen here, we have our capillary and the normal outline of the cells that line the blood vessel wall. We call these epithelium cells. Currently, because it's a blood vessel, we're going to call it the endothelium. And that endothelium, when targeted by histamine, is going to cause an increase in permeability. So we could sort of indicate this again as, remember, blue was our histamine. So when blue binds to the blood vessel, that causes that increase in the dilation of the vessel, and when the histamine, the blue, binds to these capillary cells, the capillary cells are going to blow open and they're going to create these gaps, and that gap is important for water, so water can leak out, But in addition, we also find that's helpful in allowing the margination process of different white blood cells like neutrophils and other white blood cells also to be able to leak out and get out into the tissues where they can have an effect to help the body, clean the body, heal the body. This process, the process of increased capillary permeability, is going to participate in the third feature cardinal sign of inflammation, which is swelling. And swelling occurs when the water comes out. Now, I like to think of inflammation as the body's natural casting system. So when inflammation happens and swelling occurs, this is going to help contribute to yet another one of the 4 cardinal signs of inflammation. Now, the final cardinal sign of inflammation is going to involve a different cell altogether. There are cells embedded in tissues that are known as nociceptors. Now, a nociceptor is going to be key in signaling about damage to the body and helping the brain pick up on the fact that there's been an injury within a tissue. So we're going to draw a little blue dot to represent the histamine binding to the nociceptor. When the nociceptor is bound, its job is to send one signal to the brain, and that is our 4th cardinal symptom of inflammation. That is pain. So a nociceptor is a pain receptor capable of sending signals to the brain that we have an issue, that we have inflammation. So in summary, key ideas: there are 2 general effects of histamine: to vasodilate and to increase capillary permeability. When the histamine binds to the blood vessel is going to vasodilate, giving us 2 cardinal symptoms. The first symptom being heat from the increased blood flow. It's like a mini fever to that tissue, and redness because of the increased blood flow. At the same time as histamine is binding to the cells of the blood vessel to vasodilate, it is also triggering a reaction with the individual cells that line the blood vessel, known as endothelium. And the endothelium is going to increase its permeability. When that happens, it's going to allow water as well as big white blood cells to be able to exit circulation. And that water in the system is going to lead to our 3rd cardinal sign of inflammation, known as swelling. The other cardinal sign of inflammation is pain. And to cause that signal of pain, histamine is going to bind to a nociceptor, a pain receptor, and that receptor will send a signal to the brain that says, uh-oh, danger, we just experienced some tissue damage, and the body should be aware of it. So that 4th cardinal symptom of inflammation, pain, is going to come from that unique interaction of a histamine molecule with the pain receptor. Hopefully this helps you kind of connect the pieces of the inflammatory pathways when cells such as mast cells or basophils release histamine and the specific effects that histamine is able to create in the tissues. And ideally, you understand now the 4 cardinal symptoms directly associated with the events that are starting to happen in the tissues associated with the histamine release. Have a great day.